about this thing called Newton's method, and it's basically this process that we use to be able to solve any sort of equation that's set equal to 0. So any polynomial or even any type of equation set equal to 0, we're looking for the function's roots, right? So wherever the function hits the x-intercept, that's what we're looking for. So we're looking for this root. Now, in this picture, I called the root r, right? And we're trying to figure out where r is, okay? Now, the way that we went about doing this is first by guessing where r is, right? So we weren't sure where it was, but we kind of gave a pretty good guess as to where it was. And we called that guess x1, right? Now, normally for this class, our guess is going to be given to us by the question, but we start with x1, and let me kind of write out, show what we wrote out last time. We start with our guess x1 because we really want to get to r. We find the tangent line to the function at x1, and the root of that tangent line is x2, right? So that's our new guess. Then we do the same thing. So we find the tangent line at x2, which is, and that root is x3, and then that's our new guess. We find the tangent line at x3, the root of that line is x4, and that's even closer to r. And the idea of this is as we get closer and closer and closer and closer, as we do more iterations of Newton's method, we get really close to where r is. And essentially, if we do this a billion times, we should get the value r. Okay, so that's kind of the idea of Newton's method. Now, there was a formula for Newton's method to find any value of x in x1, 2, 3, or 4. And I told you you had to memorize this. I'm actually going to ask you this formula on the quiz, so we have to make sure that we know this formula. All right. Now, one thing I did want to talk about is Newton's method isn't always guaranteed to work. And let me just try to explain how that would go about, okay? Let's say I have this function, it's curvy, and I want to find where the function hits the x-axis, so where it has a root. I want to find where r is. And let's just say I started with x1 here, okay? So I just picked x1 to be here. That's my guess to r, okay? Well, I'm going to find the tangent line at x1, and well, now x2 is all the way over here, which is actually further away from r than x1 was, okay? So I didn't get closer to r, I actually get further away, okay? Now I can do the question again. I can find the tangent line to my function at x2, and the root of that tangent line is x3. I'm actually getting further and further away from r, okay? This is an example of how Newton's method might not work. The problem here is I just made a bad guess. Okay, so my guess x1 just wasn't really that good. I just have to pick another guess. Okay, now in this class, I'm not going to actually give you a problem where it doesn't work, but just something to keep in mind in the future if you end up like coding this for assignment or doing something like that. All right. Let's do an actual question and see how this actually comes about in our class. Okay, so in this question, it's giving us x1 equals 2. Remember, x1 is the initial guess that we think the root is at, but it's probably not the root, right? We want to figure out what x3 is. So we want to get a closer approximation than 2. We want to do 2 more iterations of Newton's method. Okay. Well, we want to find the roots of this equation here. So why don't I do this? Why don't I make f equal to, well, the left-hand side of this equation, because that's what I want to find the root of, okay? So I'm going to make f of x equal to x cubed minus 2x minus 5, okay? And Newton's method involves a derivative, right? So maybe I should find the derivative of this function as well. What is the derivative of f? 3x squared minus 2, perfect. Okay. So let me kind of lead you through how we would go about Newton's method. I know that the formula for Newton's method says this. It says xn plus 1 equals xn minus f of xn over f prime of xn. So that's the formula that we have to memorize. Why don't we just start with n equaling 1? Okay, so we're just going to start where n equals 1. Okay, now this is an iterative process. It means that we have to do this multiple times for different types of n. So it's very important to stay kind of organized here. Okay, so I wrote n equals 1. I'm going to write everything to the right of n equals 1 just to keep myself really organized here. And what I'm going to do is I'm going to rewrite this formula, but instead of writing n, I'm going to write 1. Okay, so if I plug in n equals 1 into my formula, I get x 1 plus 1 equals x1 minus f of x1 over f prime of x1. Well, 1 plus 1 is 2. So this is really giving me a formula for x2. Okay. Does everyone kind of see how I got that? Okay, cool. All right, what's x1? It's 2, right? In the question, it says x1 equals 2. So wherever I see x1, I'm just going to plug in 2. This is 2 minus f of 2 over f prime of 2. All right. Once we're here, well, it's pretty easy to figure out that, I can just plug 2 into f, plug 2 into f prime, right? So this becomes 2 minus, I know that f is the cubed function, so this is 2 cubed minus 2 times 2 minus 5. The function on the bottom is f prime, so I'm going to plug that into the squared function. This is 3 times 2 squared minus 2. Okay, and I'm very bad at arithmetic. I actually did this on my own here, but I still could have made a mistake. I think this ends up being 2 plus 3 over 6, which I think is 2.5. Okay, so this is my answer for x2. You can definitely check me on that. I'm not very good at arithmetic myself. Yeah. Is it right? Is it not right? Oh God.
Yeah, 1/10.
Oh no, I did this wrong. Oh gosh. Thanks. But no thanks, because I have to do this now. Okay, 2 cubed is 8. 2 times 2 is 4. Gosh, 12 minus 2. Oh my God, you're right. So this is 2 minus
It'll be 2 plus 1/10.
2 plus 1 over 10. Oh God, now I have to do this in my head. So 2.1 is the answer, right? Is that right? Good. I am, oh gosh, I am so bad at arithmetic. It's not even funny. Ugh. All right, so we know that x2 is equal to 2.1. What this means is we want to find the root or the solution to the equation up above. I know that my first guess was 2. It's pretty much guaranteed that x2 or 2.1 is closer to the answer than my first guess. Okay, so it might not be really close to the answer, but I know that 2.1 is closer than 2 is. Okay. All right. Well, once we're here, well, we still need to find what x3 is. We know what x2 is. Why don't we make n equals 2 now? Okay, so we're done n equals 1. Let's go to n equals 2. Okay, so I'm going to go back to my red equation here, plug in 2 instead of 1. This becomes x2 plus 1, which is 3, equals x2 minus f of x2 over f prime of x2. Okay. So all I did was rewrite the equation in red, but I plugged in 2 instead of 1. All right. Well, what is x2? 2.1, right? So I'm going to take this equation, or this answer, and plug it in to what I have here. So this becomes 2.1 minus f of 2.1 over f prime of 2.1. All right, now everyone's checking me because they don't trust me anymore. Okay, so That is true. Oh gosh, so this becomes 2.1 cubed minus 2 times 2.1 minus 5. The bottom is 3 times 2.1 squared minus 2. You know, I'm gonna put you guys to work.
It's 0.061.
0.061, is that right? Oh, is that the, that's the top, okay, okay. 2.1 minus 0.061. Okay, what's the bottom?
11.23.
11.23, all right. And what happens when I subtract them? Should it be subtract? Yeah, I guess, okay.
You get 2.095 or 0.0925.
Part of me feels like it, are you sure it's not a plus or is it still a minus?
Still minus.
Still minus, okay. No. All right. Well, this is what we get for x3. All right, this is closer to the root than my guess for x2. It actually kind of does make sense. Okay. Okay, so we found x3. Taking a look at our question, we don't actually need to go any further because it only wanted us to go 2 iterations. It wanted us to find what x3 is. So we're actually kind of done. Okay, so I know that a really closer than my first guess approximation is 2.095. Taking a look at my graph of the function, the root is between like what, like 1.8-ish and 2.2. It kind of does seem like my graph is around, or my root is around 2.095. It does seem pretty good of an approximation. All right. Any questions on example number 1? Yeah. Oh, shoot, yeah. All right, while I'm passing this out, why don't you give example number 2 a try? Okay. Yeah, and why don't we do, whenever you do a decimal, why don't you do it to 3 decimal places so we're all agreeing on the decimal place? You're getting yourself into an arithmetic mess. Let's talk about this one together. I feel like there's just too much arithmetic here that everyone's just gonna get mad at me at this point. Let's go ahead and do this. All right, so we have this function here. I'm gonna let this function be f here just so we're all good. And I actually found the derivative wrong. I feel darn it. I don't know what I was doing when I did this on my paper here. Oh my goodness. Okay, so can someone tell me the derivative of this function? Good, -2/x² minus 2x. For some reason, I forgot the x because I don't know what I was doing. Okay.
I did positive 2x. I'm trying to make it so that the x² is actually the first one instead of the second one, because I just don't want to look at that.
You can do that, that's fine. Doesn't matter to me. The 2x can go first and the 2/x² can go second. That's totally fine. Yeah. All right. Well, we can start with n equals 1, right? And using the formula that we have, all we have to do is plug in 1 to that red formula I put on the last example, and this becomes x2 equals x1 minus f of x1 over f prime of x1. Okay, so just rewriting the formula, but instead of writing n, I'm writing 1. Okay. Well, what is x1 here? Good, 1.5. So instead of writing x1, I'm going to write 1.5. I need to find 1.5 minus f of 1.5 over f prime of 1.5. All right, now we're at a point where you guys are going to hate me here, but I wonder if we have a software on our computer that I'm actually supposed to be using sometimes, but oh no, we don't have it on here. Okay, well, you know what we're gonna do? I'm gonna kind of cheat here and I'm gonna use the internet to kind of help me do this calculation. Oh, did you get it?
Yeah, X2 is 1.52.
All right, anyone else get it? Okay, cool. Since we both agree with it, you know what? Let's just agree on that one. Okay, so it's not what you got?
I got 2. I got 7 at the end, but that's something that's not too far off.
Okay, yeah. Let me just show you, just so we,
Dealing with something like this crazy past I would kind of just get these ways with this for me.
yeah, like if I put this on the final exam, I'm not gonna mark off points if you get the arithmetic wrong. I think that's just crazy. Now the setup, I would be looking for the setup, but I would not be mad at you if you wrote down the wrong number. All right, so this is what x2 is, okay? When n equals 2, well, the equation becomes this: x3 equals x2 minus f of x2 over f prime of x2, right? So this is just replacing my equation with n equals 2 this time, okay? And what am I plugging in this time? So what's going into x2? Good, 1.521. So this is 1.521 over f of 1.521 over f prime of 1.521. Okay, and what do we get when we do this? Anyone get it?
1.52137.
1.52137. Is that what everyone's getting?
I'm using a little bit different.
All right, here we're gonna consult the internet for this.
Well, I think it's just how when you round
That is true. I feel like maybe we should have rounded to more decimal places when n equaled 1.
it. I didn't round.
You didn't round, okay.
I just kept the.
You kept the full decimal.
Yeah.
Why don't we go with what John said and we'll just close our eyes and pretend that it's the right answer. How about that? All right, we set it up, and that's the most important part of setting up the problem. The answer at the end doesn't matter too much unless you're like building a rocket. So anyway, besides there this is okay.
I don't know if it's right, but I got 1 point.
Yeah, I got that.
Okay, we got two people agreeing. Let's say that's the right answer. I didn't even get it right, so yeah, let's agree on this one. And you know what? If it's not right, then you can put it on my rate my professors. How about that? All right. The thing is, your calculator does this in like 0.52 seconds a billion times. So you'll never be as good as that. So just keep that in mind. All right. Now let's go to example 3. Let me just show you a different type of question that we can answer with Newton's method. Sometimes, I don't know if your calculator actually does Newton's method to do this. It might just have it preloaded. But let's just say I wanted to know what the 6th root of 2 was, okay? And I didn't know what it was. No one told me what it was. And I felt like going through a long process to find this. Correct to 8 decimal places, okay? Let me show you how you would use Newton's method for this. Now, with Newton's method, you do need an equation that you need to find the derivative of, but we don't actually have an equation here. So, is there any way we can kind of come up with an equation?
X, I don't know, like root factor.
It's not, it doesn't involve a root. Actually, it does. Sorry.
2 to the
Oh my
root of
goodness.
X. And then you
Okay, but it's not that complicated. Let me show you something that could come about. So why don't I just make x equal to the 6th root of 2? That's a little bit easier, right? All right, I think we're thinking a little too hard here. That's not really an equation, but what I can do is do this. Maybe I should just, I don't know, take the 6th root of both sides. Okay, so I can take everything to the 6th power, not the 6th root, sorry. This would be x to the 6 equaling to 2, right? Once I'm here, maybe I want to get 0 on one side because Newton's method finds the 0 of a function. So maybe I can just subtract 2 on both sides. And I am trying to find the root of x to the 6 minus 2. Right? So what I've done is I've taken this situation. I want to find what equals to the 6th root of 2. I turn this into equation equaling to 0. This is something that Newton's method can answer, right? I can find the 0 of this function. So my f here is really x to the 6 minus 2, okay? And well, I gotta find f prime, right? What is f prime of x here? 6x to the 5th, good. Okay, so when I want to find the 6th root of 2, I think a good way to start, I think it might be around like 1-ish, okay? That might be a good guess to start with. So why don't I let x1 equal to, say, 1? Okay, usually a question just gives this to you. I actually kind of know what the 6th root of 2 is, and I know it's close to 1. So why don't we just say that x1 equals 1, okay? So when we do Newton's method, we have to set up our steps here. Let's start with n equaling to 1, okay? If n equals to 1, I know that x2 is equal to x1 minus f of x1 over f prime of x1, right? Okay, so that's just plugging n equals 1 into my equation. Okay, I know that x1 is 1, so I'm just going to plug x1 into my equation, right? So this becomes 1 minus f of 1 over f prime of 1. Okay, so just plugging in 1. Once we're here, I'm going to keep that 1 the same. I'm plugging 1 into f, which is my 6 power equation. So 1 to the 6 minus 2. The equation on the bottom is 6 times something to the 5th power. Okay, so I'm just plugging in f on the top, f prime on the bottom. And I did this, this is an example in the textbook, so I know this is right. This is equal to 1.16667. Okay, so I did this. I know this is correct. Okay. All right. So we're good with n equals 1. Now the question says we want to evaluate this correct to 8 decimal places. Let's pretend that we don't even know what the 6th root of 2 is. Okay. Oh, I need more decimal places, don't I? Because we need. Okay, there we go. We got more and more decimal places here.
How many is that?
That's a lot, right? It actually just ends up being, I think it's like 7.6. Okay. I can just plug that in instead. Okay, but how would I know that this is correct if I didn't know what the 6th root of 2 is?
Calculate 6 root of 2.
Okay, pretend we didn't know what that is, or we couldn't do that.
X to the 3rd.
Oh no, that let's pretend we can't do that.
Plug into the equation.
That actually wouldn't work because it's more of an approximation. Okay, let's just keep going and see if we have any ideas going forward, okay? So let's make n equal to 2. Okay, if n equals 2, we have the equation x3 equals x2 minus f of x2 over f prime of x2. Okay, I know that x2 is the 1.6666667. So this becomes 1.666666667. I actually don't know how many decimals they went out to, probably 8, minus f of 1.666666667 over f. I'm not paying attention to how many 6s I'm writing either. Okay, and let's just say I plugged in this 1.6666667 into this equation. Okay, now I don't expect you to do this. Okay, please don't do this in your.
Put 7 over 6 in my notes.
Sure, go ahead and do that. I looked at the textbook, and it says that x3 is equal to 1.12644,368. Okay, so it's a little bit different than what x2 had. All right. Any ideas now on how we can tell if we have the right answer right to, I don't know, 8 decimal places? Well, do we think the first decimal place is right? So do we think 1.1 is about right? Okay. Do we know? I think John's getting it. All right, let's
Keep doing this until it's like the numbers stop being doubling each other from the previous one.
Yep, we're gonna repeat this until we get to a point where I promise we're not gonna set it up a bunch of times. I promise. All right, n equals 3. Let me set it up one more time so we understand how to set this up. When I plug in 3 to the equation, this becomes x3 minus f of x3 over f prime of x3. Okay. I know that x3 is the 1.12644,368. So if you would like to, you can write this out. 1.12644,368 over f prime of 1.2644368. And you can do this in your calculator if you would so like to. But I actually cheated and looked at the textbook. X4 is equal to 1.12249,707. Okay. And now we're at a point where I'm pretty confident about the first 3 decimal place, or the first 2 decimal places, right? We have 1.12 repeated, so I know that that's about right, right? I know that 1.12 is pretty close to the answer of that equation. Okay, I'm not going to set this up anymore, but when n equals 4, you should get that x5 is 1.12246,205. Okay. When n equals 5, you can check this on your own if you would like to. I'm just kidding. X6 is 1.12246,205. We're at a point now that, well, x5 and x6 actually match, right? And if I continue doing Newton's method over and over again, I'm just going to get the same, 8 decimal places that I already wrote, right? So what do you think the answer is? That, right? That this has to be the answer, because no matter how many more times I do Newton's method, I know that, well, the 6th root of 2 correct to 8 decimal places is this. Okay, so this is kind of how we go about finding correct decimal places if we don't want to go in our calculator and do it, even though it doesn't really make too much sense because it takes a lot of calculation to get here. So yeah, so this is how we can approximate a number using Newton's method. All right, any questions on example number 3? All right, I promise I won't make you do this on the quiz or test. I feel like this would be too much work. I might ask you to do like 2 iterations of Newton's method with like an easy question that isn't too much work on the test, but I don't know. I'll think about it. All right. If we don't have any questions, I think we do have a quiz review to go over.